Stoichiometry, the relationship between the relative quantities of substances in a reaction. Important? Psych! You thought wrong. If you've ever used aspirin to combat a headache or other pain, then stoichiometry has applied to you. Aspirin is an FDA-approved, over-the-counter drug commonly found in most people's homes. It is created by a synthesis of salicylic acid with acetic anhydride. Stoichiometry is used to determine how much of each reactant is needed to produce a certain amount of aspirin depending on the dosage. One dose of aspirin depends on what it is being used for, so finding the right balance is very important. For common pain, the recommended dose is 325 to 650 milligrams or 1 to 2 tablets every 4 hours. But the dose for a stroke is 75 milligrams to 325 milligrams only once a day. Now, let's do the math. First, we will calculate the theoretical yield and the limiting reactant, given that you have 2 grams of salicylic acid and 5 grams of acetic anhydride. To do this, we will use the bar and stick method to convert grams of salicylic acid to moles by dividing by the molar mass of 138 grams. Then, convert 1 mole of salicylic acid to moles of the unknown, which is acetyl salicylic acid, using the mole ratio found in the balanced equation. This ratio is 1:1 because the coefficients of salicylic acid and acetyl salicylic acid, or aspirin, are both 1. Then convert 1 mole of acetyl salicylic acid to grams of acetyl salicylic acid by using the conversion factor 180 grams per 1 mole. This comes out to be 2.61 grams or 2,610 milligrams. Now we will do the same thing but start with 5 grams of acetic anhydride and convert that to grams of acetyl salicylic acid, again using the bar and stick method. This becomes 5 grams of acetic anhydride times 1 mole of acetic anhydride times 1 mole of acetyl salicylic acid times 100 grams acetyl salicylic acid, and all divided by 102 grams of acetic anhydride times 1 mole of acetic anhydride times 1 mole of acetyl salicylic acid. This comes out to be 8.82 grams acetyl salicylic acid, or 8,820 milligrams. Because the amount of salicylic acid we have makes less acetyl salicylic acid than the amount of acetic anhydride, salicylic acid is our limiting reagent, and acetic anhydride is our excess. In this case, our theoretical yield is the amount that can be made from 2 grams of salicylic acid, which is 2,610 milligrams of aspirin. If you divide our theoretical yield of 2,610 milligrams by the recommended dosage for a headache, which is again 325 to 650 milligrams, then you will find that there will be 4 to 8 doses of aspirin made from 2 grams of salicylic acid and 5 grams of acetic anhydride. Percent yield is used to show how successful the reaction in an experiment is. To find percent yield, you place the actual yield of 2.08 grams of aspirin over the theoretical yield of 2.61 grams of aspirin and multiply this times 100. This comes out to be 79.7%. This means that our experiment produced 79.7% of what it theoretically should have.